All right, so here we are with our last section of chapter 6, so 6.5, which is graphing polar equations. So we're going to do a lot of this on our calculator, but of course you could do them by hand if you feel so obliged. Um, yeah, remember that there is a graphing calculator accessible on HeadRush in your resources category. All right, in the first page. So first thing that you want to do when you're talking about graphing polar equations is you're going to want to make sure that your calculator is in polar mode. So when you turn it on, you go to mode, and hopefully you are in polar. We do tend to graph in both radian and degree, but of course, since we think a little bit more in degrees, you may want to have that reference in there. So first thing that's happening here is we kind of already talked about in the last lesson, but again, notice that you're going to have R in equals in your Y equals button, so watch for that. And then theta, again, is going to be your X key. So this key here, when you press it, is now, instead of X or T, it's going to be theta. So that's that one. And our window, of course, now has a theta minimum and a maximum. So that is what we're going to use today, especially when they ask you on what interval will you get the full picture. And so you're going to want to change this interval so that you can change how far the graph is being pictured. So this first graph here is our rose curve. So anytime that you see like a number times cosine, and then maybe even a number inside times theta, or a sign in that same format, you are going to get this rose curve. So that's the shape that's going to occur. And depending on what each of these numbers is, you're going to get a certain number of petals. So we'll go over that. So that's your rose curve. You're also going to be talking about your limacon. So that's kind of an S sound. So limacon versus limacon. Anyway, and so there you go, limacon. The idea is that this kind of looks like a lima bean, okay? And so each of these is kind of its lima bean shape here, and those are going to be when you have, instead of just a cosine and a sine like we had here, you're now going to have a number added out in front. And so when you add a number in front or behind, you're going to get this kind of lima bean shape. Technically, each of these has a little name here. So this is the limacon with an inner loop. It's got that circle there. This is a cardioid, so like a heart, right? This one is your dimpled because it's not as big as a cardioid. And then over here, we've just got the convex, which is actually kind of more like a circle. So those are your pieces of a limacon. There's also the spiral of Archimedes. So this doesn't use any cosines or sines. Notice that it's just a number times your theta. So in that case, it's going to make a spiral depending on how large your theta is, what you're going to input. So that's your spiral of Archimedes. And then we also have our lemniscate. All right, so our lemniscate curve is actually kind of like an infinity symbol. The problem, of course, with the text on your calculator is that it's not going to necessarily show, unless you have the super new color calculator, it's not necessarily going to show that this connects here. And so you may look at it and think, but that's just like a half circle-y thing. But it does actually connect. It's just that the pixels on your calculator don't necessarily show up. So this is when you have an r squared, but of course, when we graph it, we don't have the option of doing r squared. So you have to square root to move it over to the other side. And this is where you're going to get, again, a square root of the original one here, which was the rose curve. So notice a cosine n theta, or in this case, a cosine 2 theta, square rooted. So the first piece, rose curve, with a square root around it. So very short lesson on that, because basically you're just going to be using the calculator in the assignment to figure out what each of these does and where its domain is. So That is your 6-5 assignment, and that was your 5-minute lesson. Super.